Greetings, ladies and gentlemen. Here we're going to talk about LeChateliers principle today. LeChateliers principle simply says that if a system is at equilibrium and it is disturbed by a change in concentration, pressure, or temperature, the system will shift its equilibrium position as to counter the effect of the disturbance. If you want to look at the 13th edition of the chemistry textbook on page 651, there's an infographic showing you how concentration change will cause an increase in a concentration, will make it shift so there's more concentration on the other side. But you can look at page 651 if you have one. If you do not, then you can just follow along with my disturbances, shift in equilibrium, and will it change the equilibrium constant table. All right, here we go. Here are the disturbances. Disturbance number one is if you increase the concentration of a reactant or a product, you will force the equilibrium system to shift to the opposite side. Shift to the opposite side. There will not be a change in the numerical value of K. If you decrease the concentration of a reactant or a product, it will shift to that same side of the reaction. It will shift to that same side of the reaction. There will not be a change in the value of the equilibrium constant. Remember, brackets mean molarity or concentration. So if you forgot about that already, you can write down the word molarity down here because that's what those brackets mean. If you increase the if you increase the pressure of a system, increase the pressure of a container, it will shift to the side with the least moles of gas. It will shift to the side with the least moles of gas on that particular reaction or system. No change in K once again. And if you decrease the pressure of a system, it will shift to the side with the most moles of gas. Decrease the pressure. There's a tricky way to say these because you know something from chapter 10 about the vice president gas law. Remember, if the volume goes down, if the V goes down, the pressure goes up, or conversely, if the president goes down, the vice goes up, so the P goes down, the V goes up. Remember, they'll probably talk about volume here just to confuse you, and then you'll have to determine what happened to the pressure. Last one, change in temperature. If you increase the temperature or decrease the temperature, here's the trick to identifying these. First of all, treat the enthalpy, if it's positive, as a reactant, or treat the negative enthalpy, exothermic, as a product. Write the word heat in the reaction. Treat an increase in temperature as an addition of a concentration of this delta H, and then shift to the opposite side. So treat it just like a concentration right here, but you have to write the word heat in the correct place. If you decrease the temperature, remove the delta H and shift to the same side. That's an example for you. And these are the only ones that change K. These are the only ones that change K. Now, once you've got this table written down, then I'm going to move into lots of example problems using each one of these. So if they don't make sense right now, that's okay. You'll see an example of each one multiple times. I'm going to move this to this side. You can continue writing these down if you want. And I'm going to give you one special situation that has nothing to do with this, but it's like a trick question all the time. Here's the special one. An addition of a catalyst to a system. Do you remember what you call a record of your cows and bulls? Yes, that would be a catalyst, of course. Okay, and if you add a catalyst to a system, you do not change K, and you do not change the shift or the position of the equilibrium at all. All you do is you reach equilibrium faster because you speed up the reaction. You speed up the reaction. So there's no equilibrium shift, but you reach equilibrium faster with the catalyst. So watch out for that trick question. It'll say, does it shift left? Does it shift right? Are there more products? Are there more reactants if I add a catalyst? And you'll say, nope, doesn't shift anyway. It just speeds up the reaction. All right, here's the example problems. Lots of examples. Here's my reaction example. 2NO plus O2 goes to 2NO2, and then it has a delta H equal to positive 100. If you forgot what delta H stands for, remember it stands for the word enthalpy. Enthalpy is also known as heat at constant pressure, and since it's positive, that means it's endothermic, E-N-D-O, endothermic. That means you would write the word heat on the reactant side because it is added to the system. If it was negative, it would be exothermic, and so you'd write the word heat on the product side over here because it would be given off or produced. So as you're finishing writing these down, I'll reveal about 5 different examples here in a row of stressing this system right here, putting a stress or a disturbance on the system. The first disturbance is that oxygen is added to the system. Oxygen is added to the system. So if I add O to the system, I am increasing the concentration of oxygen. If I increase the concentration of something, the shift in equilibrium would cause it to go to the opposite side. And so if I add some of this O2, it should shift to the right, or there should be more products. And so my answer for letter A would be shift right, or I could say produces more products. Or I could say makes more NO2. Any one of those answers is okay. Okay, second example. NO is removed from the system. NO, not the word no, but NO, this stuff right here. So NO is removed. So now we're taking some of this away. If you remove some NO of the system, it's like we're decreasing the concentration of that stuff. If we decrease the concentration, what happens to the reaction? Well, it shifts to the same side as where NO is. And so we'd say that there would be more of this stuff replaced. Maybe there'd be a decrease in NO2. And so we'd say that it would shift left, or shift towards the products. I'm sorry, shift towards the reactants. Shift towards this side of the reaction where the NO is, because we decrease the concentration of it. Okay, letter C. If the pressure of the system is increased, pressure of the system is increased. If I increase P, it says it will shift to the side with the least moles of gas. So now you need to be good at counting. First of all, you need to know if they're gases or not. So here's gas, 2 moles of gas on this side, because there's a 2 in front of here. This is a gas, 1 mole. This is a gas, 2 moles. What's 2 plus 1? There's 3 moles of gas on this side, 2 moles of gas on this side. It says it will shift to the side with the least moles of gas. So that means, since we're increasing the pressure, it would shift to the right. It would shift to the products. It would shift and go to more NO2. Last one, temperature is increased. Now this is the trickiest one for lots of people, because you have to take H and you have to write it as a reactant or a product. And since it's positive right here, it means it's endothermic, which means heat is added to the system, so you add it as a reactant. And so you actually take this reaction and write the word plus heat on this side of the reaction right here. Put the words plus heat so you know it's a reactant. Now that you know heat is a reactant, you can increase the concentration of that reactant. And so if I increase the concentration of something, what will happen to it? It will shift to the opposite side. And so if I increase the heat of this reaction, it should shift to the right, and it should produce more NO2. All right, I have more example problems for you using a different reaction. And so if you want to keep this sheet out in front of you, I'm going to remove this one, and then I'll give you more example problems. And then if I run out of time, I promised only 10 minutes and I'm at 9 already, then you can always quit along the way. But if you want more examples, here they are. There's a new system. N2 plus 3H2 goes to 2NH3, and here's the enthalpy, negative 92 kilojoules. Notice they're all gases. Notice it is a negative sign right here, so that is exothermic. That means if you wrote the word heat, you would write it on the exothermic side or the product side. So you would write plus heat over here if you need to, over here because it's negative. But the first question says decrease the pressure. If I decrease the pressure, what does it do? Shifts to the side with the most moles of gas. All right, let's look and see if they're gases or not. Oh yeah, gas, gas, and gas. 2 moles of gas on this side, 3 plus 1, or 4 moles of gas on this side. Which way would the reaction shift? should say to the side with the most moles, which is this side right here. And so we would say that the reaction would shift left, or to the reactants. Second example, temperature is decreased. Oh, now you have to have the plus heat in here. And if I decrease the temperature, I'm decreasing the amount of heat right here. I'm decreasing the concentration of heat. And what does it say is going to happen? It would shift to that same side, correct? So it should shift to the right, and it should shift to the products. Or you could say to the products. You could say that to the NH3 side. That would be okay to say as well. Letter C. An iron catalyst is added. Ooh, remember this one? This one's a tricky one. Does it shift left? Does it shift right? Does it change anything? Remember, the addition of a catalyst has no effect on the equilibrium. You just simply reach the equilibrium faster. So that's a trick question that shows up. And the last one. The volume is decreased of the container. How are volume and pressure related in gases? Remember, if the pressure goes down, the volume goes up. Remember, pressure goes down, vice goes up. So if the volume is decreased, so the volume goes down, that means the pressure's got to go up. So by saying this, I'm actually asking, if I increase the pressure, what will happen? Oh, it will shift to the side with the least moles of gas. Well, who has the least moles of gas? There's 4 on this side, 2 on this side. Oh, it should shift right. And it should shift to the NH3 or to the products. Good luck on your LeChateliers principle problems.